just like solving a system of linear equations, we can use the substitution and elimination methods. We can do the same thing with nonlinear equations. So we're going to look at an example of the substitution technique or substitution method to solve a system of nonlinear equations. So our first example that we're going to do is going to be the system x squared minus 2y plus 10. And we're also going to use 3x minus y equals 9. Now, when you are trying to do the substitution method, again, you need the variable that you are trying to substitute for to be like a y equals or an x equals. And so for this particular problem, it would be a lot easier to do substitution if we could isolate the y term in the second equation. Now right now it's a negative y, so I'm going to modify this equation, and I'm going to bring the 9 to the left hand side and the y to the right hand side. And now I can use substitution for y in the original or the first equation in the system. Now typically when you do substitution, you want to avoid substituting for maybe something squared, and I would avoid solving this for x just because that will give me a fraction. So if we can avoid fractions, that would be good. So now I'm going to go into the first equation, and I'm going to substitute for y. And we can see that I'm going to end up with a quadratic because I have an x squared term. And so I'm going to want to move all of my terms to the other side. Again, these two right here are like terms. And so I'm going to leave my x squared where it is, and I'm going to bring my 6x to the left. On the right hand side, this is negative 8. So when I move it to the left hand side, it becomes a positive 8 equals 0. And now I have a quadratic that I can use to solve using the factoring and zero product properties. So two factors that multiply give me 8, add up to be a negative 6. It's negative 4 and negative 2. So the two values I have are when x equals 2 and x equals 4. So these are the x coordinates that I would get when I graph these two equations and I look for their intersection points. So what I have is I have a parabola that is intersecting a line. And so I am going to have 2 points of intersection here. And so one of the coordinates is when x equals 2. Well, I need to plug that in and figure out what the y coordinate would be as well. And in this case, I get negative 3. And for the other coordinate, I'll just multiply it like this. I'm going to get positive 3. So the solution to this system are going to be the two coordinates when x equals 2 and y equals negative 3, and when x equals 4 and y equals positive 3. So using the substitution technique is doable, especially if you can solve one of the equations for a 1y or a 1x.